Section 4, Video 1, Postulates and Theorems. So what kinds of things can we use for reasons in proofs? Well, these are some very powerful ones. The first one is parts to whole theorem. And that states that the measures of the whole figure is equal to the sum of its parts. Now that doesn't make a lot of sense with words, but if we were to draw pictures, it makes much more sense. So if I have a triangle, or excuse me, an angle, and I create another angle, and I draw a ray which creates two angles, so we'll call this angle 1 and angle 2, and we'll say that we'll put some points on here and say this is angle P, Q, R. We can say that angle 1 plus angle 2 is equal to angle P, Q, R. So the two smaller parts add up to the larger part. If we were to make a line segment and say A, B, C, we would say that AB plus BC, the line segments, would equal the whole segment AC. So, parts to whole theorem, very powerful, very useful. We'll see later as we go. Next, congruent supplement theorem and congruent complements theorem. Very similar in nature. Obviously the difference is supplements and complements. What they're saying is this: if two angles are supplemental to the same angle, then the two angles are equal. And the complements say the same thing. If two angles are complementary or complements of each other, I'll just say complemental, complemental, to the same angle, then they are equal. So what does that look like? Well, if I have angle 3 and angle 2 and another angle over here called angle 1, and I say that angle 3 plus angle 2 equals 180 degrees, they are supplemental. But if I say angle 1 plus angle 2 is also equal to 180 degrees, then you can conclude that angle 1 must be equal to angle 3, because both of these angles 1 and 3 plus angle 2 add up to 180, so they must be the same measure. And this ends Section 4, Video 1.